Hi, good morning. Today we are going to study conservation of momentum and impulse, and just this is gonna be lab 8, which is virtual impulse lab. Now we are going to run several collisions and check the total momentum of the system and also the total kinetic energy of the system. Of course, this lab is going to be a formal lab report where you need to submit both the Excel sheet and the formal lab report. We know that from the lecture, we defined momentum as m times v, and we are going to use this relationship to calculate today momentum. And k, it is 1/2 mv squared, where of course m stands for m mass in kilograms, and v, it is the velocity in meters per second. Now we know also that when we don't have any external forces acting on the system, then sigma f equals 0, and we can say there will be no change in the momentum. And therefore, if we have a collision, like I want you to read this one here, if we have a collision where we don't have any external forces, all the forces are really internal, I can apply conservation of momentum. Mass 1 times v1 plus mass 2 times v2 equals mass 1 plus v1 prime plus mass 2 v2 prime. v1 and v2 stands for velocities before the collision, and v1 prime and v2 prime after the collision. Of course, also we were talking about elastic collisions where the kinetic energy for the system is going to stay the same. Of course, also we discussed during the lecture the momentum conservation for completely inelastic or totally inelastic collision. Today we're gonna have so many scenarios. We are going to use the PHYS collision lab. I will show you in a minute, and here we're gonna have different scenarios. I will show you how really to work on one of these. I will share with you my Excel sheet and how I did things, and now the only difference is that my masses, they're gonna be different from yours. You have to use 0.9 kilograms, and every time you are going to run the simulation, you need to record the masses and velocities before and velocities after. This is what is going to be in your data section, and for the first attempt, we are going to have this stationary impact, which means the mass that is going to be hit is going to be at rest, and both masses are equal. And then we are going to have the second attempt where we're going to have heavier impactor, means that the mass that is going to hit, which is mass 1, it is 2.90 kilogram heavier significantly than the second mass, which is 0.75. Okay, lighter impactor, of course the one that is gonna hit is gonna be light. Now in 1, 2, and 3 we have the target mass was stationary. Now in the part 2 is gonna be again elastic, but we're gonna have moving impact, which means both masses are really they are going to be moving. We are going to consider also elastic collision where the masses are equal, where the impactor is heavier, and where the impactor is lighter. Part 3, we are going to talk about completely inelastic collisions where the masses, they're gonna stick together, and we are going to do stationary impact, and we are going to do moving impact, and then In the section which is called the calculation section, you need to include all the total calculation momentum before and after. Calculate the percent difference between the initial and final momentum for each attempt. Make this a separate section. Percent differences. Your results, they're gonna show, you're gonna show this table in the results section. Type of the collision, PI for each, summarize the values, P final, what is really the impulse. Remember, the impulse is the change in the momentum, percent difference, and kinetic energy initial, kinetic energy final, and the percent difference. Okay, then this is in, I would say, in summary, what is really the lab about. Now this is here the collision lab, and in the when it's gonna say elastic, you are going to put it at 100. Completely inelastic, you're gonna put it on the 0. Okay, then for the first ones, I'm gonna have like 100% elasticity. I can change the masses here. Okay, for my values, I will have, let's say, equal masses 0.5, and that one also 0.5 as well. Okay, then here my masses are really equal. Now I will say more data here, and then here where is going to show you velocities. Then I will say for mass 1, let's say 1, it doesn't matter. For mass 2, I want to have it stationary. Then I will, this is the situation. You know, here the initial velocity before is 1, and the initial velocity before v2 is 0, and then I'm gonna just and have the velocities after. This is the velocity after, this is the velocity after. I will record them as easy as this. You're going to go over different situations. Okay, for example, let me change this one at to be 1.5, like this is the lighter impactor. Okay, and I'm gonna have that and let's have this 0 also. Okay, then I'm gonna have the lighter impactor case, and then okay, then you're gonna record the velocities here. Okay, you don't have to worry about the position. Okay, and here when we start beginning, like we're gonna just have that velocity highlighted. Okay, now I will go to my Excel sheet here. For example, this section is gonna show into my data part of the lab. Then I will say ball 1, ball 2, mass 1.5, most, you know, for my first, and this is my final. For the calculation, I will have again other masses, and then I will multiply velocity, mass times velocity to get momentum. Initial, momentum final, I'm gonna multiply also mass times velocity. I will go for mass 2, I will add again I will add here the mass, and then here is gonna be also mass times velocity is gonna give me the momentum of ball 2 before and momentum after for mass 2. I can say here P I total, you're gonna add here 0.5 is gonna be this one plus this one for the total momentum. This is gonna be the total momentum for both, and you can see these numbers, they should be the same. For this one here, I have calculated what is going to be the total kinetic energy, then I will start with mass 1 before collision, 1/2 mv squared. Then I will say this is the kinetic energy for ball 1 before, and this is the kinetic energy for ball number 2 before. You add them, this is the total kinetic energy of the system. And for the final, I have calculated 1/2 mv squared for mass 1 after, and 1/2 mv squared for mass 2. And then you can see, since this is elastic, I have the two here equal. I can I can calculate the impulse received by mass 1, which is going to be its final minus initial. You can see here d10 minus c10, and that is going to be 0 minus 0.5, and that is going to be negative 0.5. And I can calculate this is the impulse received by mass 2. Now, if you look at my Excel sheet also, I have it like equal masses, heavier impactor, lighter impactor, moving equal. I need to label them: moving heavier impactor, moving lighter impactor, inelastic stationary, and inelastic moving. Then you need to label also your here I will say sheets, so that they will reflect which scenario you are talking about. I hope this lab is going to be very straightforward with no problems. If you have any, of course the rubric is there, and if you have any issues, please contact me as early as you can. Thank you.